Hi everyone, welcome to my software developer diary where all good ideas live. No, this is not about microbiology, although at the end of this video I will explain why I put that DNA picture behind me. In this video I'm going to share with you the things that happened as our team was working on a recent project. This could be interesting because it is about the test-driven development, how test-driven development is applied, how it can go wrong especially, how to fix that, and refactor a code that is covered with unit tests. But first, let me tell you a few words about what happened that I've decided to record this video. Our team started a new greenfield project, and we decided that we will make it right this time, since we had all the key decisions were ours, like the design decisions and decisions on the process. So we decided to go agile, to do a test-driven development, to do a pair programming, to write all kind of the tests, like integration tests and end-to-end testing through the UI and all that stuff. And we thought that we are ready to embrace any change, that we are ready to implement any new requirements. And at first everything were going well, we were delivering the feature after feature, but then the presentations have started and the last minute changes appeared, and the deadlines were getting shorter and the pressure started building, and we have realized that the tests that's supposed to help us go well and go fast are standing in our way. So they making our life harder, and first thing that we had to do is it was a hard decision, but we had to do it because we had no way to move further. We had to abandon the end-to-end tests. In fact, we have abandoned them earlier. We stopped supporting them because it was taking an enormous amount of time. And the only thing left is the unit tests and integration tests that we had. But then we had to implement the new requirement that were on our list for a long time, but the time has come to implement one of the core features of the application, as we realized that our current architecture is not suitable for implementing this feature, so that we need first to refactor our code and change the design of our system to implement that new requirement. And we realized that the rest of our tests is standing in our way also. That any little change to the code causes us to hop around the system, fixing the compilation errors here and there. That it takes a lot of time to support such tests, especially when you're working on the when you're trying to modify code, and when with the last minute changes we had to switch to test after, like we were changing the code, and then after this we were fixing it and fixing the tests. So it was very frustrating, and I was literally scratching my head trying to understand what was wrong, what we did wrong, and how to fix that problem. And I decided finally to commit the experiment, in which I created a small test project so that I can fiddle with it and try different solutions quickly. And in this small test project I have repeated all the steps that we had. I have simulated the process that we had, and I've repeated the key design decisions that we made. And the results of this experiment was so surprising, and I've learned so much, that I decided to record this video to share it with everyone. In this video, I will, in the next part of this video, I will do a coding session when I will record how I created the project. After that, I will go and do a little code review to explain what I did wrong, what was wrong about the test, what was wrong about the design and what was wrong about the process. In the next part, I'll do the refactoring. I will fix the code, fix the tests, and clean up the system, redesign it, and implement the new feature. And in the last part, I will explain what I did, why that helped me, what conclusions I've made, and what lessons I've learned. And probably I will explain why the DNA is out there. So without further ado, let me grab my keyboard and start getting myself into trouble writing a simple calculator program. Let's get started getting ourselves into a trouble. Imagine that we have just started the project and we have the requirement to write a calculator program, and in some time there will be a presentation, but we have to go clean, we have to go well, we have to write tests first. So let's start with writing a simple test. But first we have to imagine that we had a design session with the team, that we decided that for the first version the calculator will be console based, and we will probably capture the user input into some data structure called calculation. Then we will pass the data structure to the operations factory, and the operations factory will produce us the operation, the class that will execute this calculation. We will call the execute, get the result, and pass it over to the console. So that's the design ideas. So let's get started implementing it. The first test, I'm going to test that the input is captured correctly. Reading input. Okay. So as usually as recommended, I will start with an assertion. So I will start with an assertion that operation dot argument 1 should be 11, that the operation argument 2 should be, let's say, 2, and operation dot no, not operation, calculation. It's a calculation data structure. Okay. Calculation operation should be, let's say, multiply. So where I get this calculation? Calculation will be provided me by the input reader. Okay. And what's the reader? It's the instance of an input reader. I will give it an input, okay, to read from some interface that will represent the console input. I don't have an input reader class. Let's go and create it. Okay. Now, what's the input? Well, the input will be a mock object, substitute for some input interface. I don't have one, so I have to go and create it. Okay, it's an interface. Fine, let's go back to the test. I have to create a constructor in the input reader, and I have to create the read method. The read will return a calculation data structure. Let's move calculation to the separate source file. Let's clean up things a little bit. Now, but the input should be providing me something. So read argument 1 returns 11. Input read argument 2 returns 2, and input read operation returns multiply. Exactly what I've been testing. So I have to create these methods. Let our calculator for the first version to be working with the integers. So the argument 1, read argument 2 returns an integer, and the read operation returns a string. Now the calculation data structure should have properties. So the integer is just a simple data structure. The argument 2 is also an integer, and the operation is a string. Okay, let me import references. So if I run that test, it should fail. So the project gets compiled, the tests are running, and it fails. And it fails because the method or operation is not implemented. I have to implement the constructor for the input reader. Okay, I got it. And the read operation. Read method will just return a calculation data structure, initializes properties with what input provides. So argument 1 will equal to input read argument 1, and the argument 2 will be equal to input read argument 2, and the operation will equal to input read operation. And now my test should pass. Oh, great, great. The beginning is done. We are going well, so we have a first test written. So now the manager kicks in, and the manager tells us that the presentation will happen real soon, so we have to hurry. We have to deliver the 4 basic features, 4 basic operations for the calculator in order to show them on the presentation. So fortunately that's very easy. We're doing a test first, we're doing a test during development. So let's implement multiplication operation. Or no, let's start with addition. Okay, so 11 plus 2, the operation will be add, and let's see. Now we will assert that result should be 11 plus 2 is 13. Where I will get this result? Well, result will be provided by operation execute method. Where I will get that operation? Well, from the operations factory, of course. Create, I will pass in the calculation that contains the operation property, and the operations factory will return me an operation to execute. I don't have this class, so let's create it. The operations factory, it's a static class. It will have a static static method returning an operation, that create method, and will accept the calculation as its argument. And I have an operation class. Let's create it. And it's a abstract class that will contain public abstract method returning an integer execute. Fine. And let's move the abstract class into a separate source file. We have to go clean, remember. Despite that the presentation is very soon, we have to go clean. Calm down. And we will return a new addition operation passing in the calculation. Let's create that class, okay, and let's implement the abstract method Fine. So my code is compiling. It's time to run the tests. Okay, method or operation is not implemented. So I have to implement the constructor for addition. Let's capture this calculation to a private field, and then we will return calculation argument 1 plus calculation argument 2. Let's move it into a separate source file. Okay, and run the tests. Okay, now the presentation is getting closer and closer with each day. It's the middle of the week, and we still have 3 operations to go. So come on, there's no time to waste. Let's do it. Write a test first. So multiplication, our next operation. Multiply will be the operation. The reader will be reading this input, the calculation, the operations factory. So 11 times 2 will be 22. Let's run our tests. Oh, the multiplication test fails because we expected 22 but got 13. It's still an addition. Let's go to the operations factory and return an addition only if we add to. So if the operation equals add, then we will return an addition, otherwise we will return new multiplication operation given a calculation. So let's create it. Let's create a class. Okay, we're rushing, so we don't okay, so I already know what to do, so I don't need to run the stupid tests again each time. I need to return the calculation argument 1 times calculation argument 2. It's real simple. Let's run the tests. Okay, fine. Let's move it. Let's move it to a separate source file. So we're trying to go clean. We're trying to go clean. The presentation is very soon, but we're still writing tests. Okay. So it's a Friday. It's Friday, and Monday we'll have to have a presentation, but we have 2 operations to go. We have to be real smart to meet that deadline. So we'll go and create the subtraction operation. Okay, what's the subtraction? 11 minus 2 subtract, and 11 minus 2 is 9. Okay, so we already know what to do. Let's go to the operations factory. Okay, let's go to the operation, create a new derived type called subtraction, and okay, it's a subtraction. I implement the execute operation and the constructor accepting the calculation. Okay, execute, return the calculation dot argument 1 minus calculation with argument 2. Fine, subtraction. Okay, move to not class, and let's get back to the operations factory. And if we've been asked for multiplication, then we will return a multiplication. Otherwise, we'll return our new subtraction class passing in the calculation. This will make our test pass, I believe. And it does. Okay, it's Friday evening. We are about to go for a beer with our team, but we still have 1 operation to go, so let's do it quickly. Let's do it real quick. We already know what to do. We're going well. We're writing test first. We're going well, aren't we? So subtract is ready. Division operation. Okay. Divide. And, well, 11 by 2. Not very well. Let's say it will be 10 by 2. 10 by 2 is 5. Easy. So the division. We go to the operations factory. Okay. If calculation dot operation operation equals subtraction, so we'll return a subtraction. Otherwise, we'll return division operation given a calculation. Let's create a class. Okay, fine. Let's capture the calculation. Let's implement the abstract class. Let's return the calculation argument 1 divided by calculation argument 2. Okay, it's couple of hours, and we will be in a pub with our team having a good rest. Okay, so do our test pass. Oh, subtraction is failing. Why it fails? Expected result to be 9 but found 5. So we're executing a division. Oh, yeah. Subtract. Oh, that last minute things that happen always when you are in a hurry. So, okay, our tests are all passing. That's something that bothers me. Although guys are waiting for me in a pub, I have to write yet another test. Another test will be real simple. If I got the unknown operation, I have to throw an exception. So I will write a test for unknown operation. Oh crap. Operation. Okay, I don't need this too. Unknown, so that everybody knows what I'm testing. Input, the calculation, the operation. Oh, okay. So the create action is a lambda. So the create action should, in this case, throw me the unknown operation exception. I will not use the generic exceptions. I'm a good software developer, although I'm a little bit in a hurry. I will create a class, derive it from exception. Okay, fine. And lastly, in the operations factory, I will return a division only if I ask to. Okay, otherwise I will throw this new unknown operation exception. Will my test pass? Yay! Great! Everything's working, so I can go and grab myself a beer because I really deserved it. This was a hard week. In the Monday, the presentation will be ready. Okay, so fine. I did everything. I'm proud of myself because I was going to test first. I did everything, although I was in a hurry, but I did everything that the professional software developers do. Okay, that's great. Let's grab myself some beer. And so that's how it goes. We have implemented the core features, 4 features of our application, the core features. For those of you who are really familiar with this book, I wasn't doing test-driven development at all. Because test-driven development is a process that has at least 3 phases. First, I write a failing test and see that it fails for the right reason. Next, I write a production code to make this test pass. And then I do the refactor, where I remove the duplication and clean up the code. As you have probably noticed in the previous section, I have completely omitted that refactoring phase. And I was adding the test after test, just copy-pasting those, and the features were implemented in no time, and everything seemed to go well, kind of. That's because I was adding the new code. I didn't have to change anything. I was adding the new code, and my test suite was growing, my code was growing. And now it's time for the morning after syndrome. The manager comes and it tells that the presentation was very good. Everybody loved it. Everybody was happy. The customers was happy. And that they decided to commit another presentation in a couple of days, and that in order to show that we are doing a good progress, we need to implement yet another operation, the negation operation. Real simple. It's just you enter the number and the calculator gives you the negative to this number, and we will start looking at the code to see what can be done. That's where things start getting trickier. Let's look at the code. So, we have a calculation that has two arguments. As we remember, the negation operation requires only one argument. This is the number to negate. And let's look at the input reader. The input reader always reads two arguments. Well, the presentation is really soon, and kind of what can be done. You see these two arguments here, and let's look at the tests. Right about every test knows how to set up these two arguments, and if we just change the input reader and read the operation here, and then request only the number of arguments that we need, because you know what, if we'll, for the negation operation, if we'll ask user for the second argument, I don't think that this is what user asks us for. So we need to be able to ask only one argument for the negation. But the tests know about, all the tests know about the two arguments, and the calculation data structure contains two properties for the two arguments, and the input reader knows about two arguments, and so the whole system has to be changed just to implement that simple operation. And worse than that, we have to fix a lot of compilation errors that will appear in the tests. So that's the problem. That's the problem that we have. And well, let's start fixing that problem. So first we'll go to the tests and fix the problem that we have created when we omitted the refactoring phase when we were writing tests. We omitted that phase, and we were quickly hopping from failing tests to passing tests, failing test, passing test, failing test, and passing test without any refactoring. Now it's time to do the refactor. Now it's time to pay back the technical debt that we created. So let's look at these methods. They have a lot of duplication. The most obvious is that input is being configured every time in every single test. Probably we can extract this as a method and just provide the arguments that we need to have the input to return. So, but first let's think about carefully about this reading input test. It's testing that we're reading the input correctly from this input interface. But let's think about it for a moment. This is what all the rest of the tests do. So if we just drop this test, will we lose any confidence in what we are doing? I don't think so, because all the rest of the tests will be reading the input. So there's no harm in just deleting this unnecessary test. It's not necessary anymore. It was necessary to create the input and to wire up things, but it's not needed anymore. This test needs to be supported, but it doesn't pay off for its existence. So I will just delete it. Now, what's left? So this setup for the input, let's refactor it and create a method. So let's extract this as a variable named argument1. We'll extract this as an argument 2 and extract this as operation. Okay, maybe not a very good name. Let's name it up for the moment. Let's move this all up a little bit. So, and we can extract this as a method called given input. Returns. Given input returns. Okay. So it returns us a configured input. We can inline this arguments back. So, and we can rewrite our tests. Let's move this method way down because it will be used by all the tests, and we will rewrite our tests to use that. So 11 and 2 will be pretty much everywhere. So let's replace this with this. Multiply. This will be subtract. And this will be divide. And we have to remember to change arguments. Divide 10 by 2. So do our tests still passing? Yes, they do. So okay, but we still have a bunch of duplication here. So we set up the reader, we create the calculation, we create the operation, we execute the operation. Can we just do something like this? Can we extract all this as a method? And name it something like way down to the getting the result, and name it execute operation. So now we have much shorter tests. So something like, yeah, and we can inline this. Execute operation add given 11 and 2 should be 13. It reads nicely. So, and this method will go way down, and we can replace all the rest with this. Execute operation, and down to this should. So okay, execute operation, and same to the division. So we'll go here, execute operation, do our tests still pass? They do. Can we replace it here? Well, I believe we can. So in the lambda we'll call the execute operation unknown and do our tests still passing? They do. Great. So we have removed a bunch of duplication here. But is there still a duplication? Yeah, I believe it is. So we are calling execute operation all the time in 4 places. Can we collapse these tests to be... what I can do is to create a theory and provide they are different only in arguments, so I can provide these arguments to the test itself. So the operation, the argument 1, argument 2, and the result, expected result, and I can accept this as an argument. String operation integer argument 1, integer argument 2, and integer expected result. So now I can pass this in here. Operation argument 1, argument 2, expected result. And I can eliminate these tests and align their data into the theory, so I can basically add, multiply, subtract, and divide. And this 10. So multiply 11 by 2 will be 22. Subtract will be 9. And divide 10 by 2 will be 5. So I have the same number of tests. As you will see here, I have the same number of tests for add, divide, multiply, and subtract, and they all pass. So with this, I believe I removed all of the duplication in my tests. Well, at least all I can think of. Now it's time to refactor the production code and fix the mistakes that I did. The first mistake is that I created the calculation data structure. It's a dumb data structure that does nothing, except that it exposes the fields. And I made the whole system dependent on that fields, which is wrong. So, and what I have to do with the dumb data structure is to move all the operations that using these fields into this data structure and make these fields private to make the calculation expose only the public methods. How can I do this? Well, let's see. What classes are using this data structure? For example, the addition is using calculation. And this code here, can I move it to calculation itself? Well, I believe I can. So if I create the add method in the calculation and return the result of it from here, then I can write something like this here, and my test will be still passing. They do. So can I go and do this with a subtraction? I believe I can. So I will create that method and move the logic in here. Argument 1 minus argument 2. And my test will be still passing. Fascinating, isn't it? I don't have to change tests. Let's see if I can do this with the division operation. Return calculation divide. And I'll create that method. Return argument 1 divided by argument 2. And this will not fail. Even compilation is not, compiler is not complaining. So the multiplication, okay. So let's move the multiplication there. Return argument 1 times argument 2. And I believe my tests are still passing. Now, who else is interested in these fields? Well, I can see that except the calculation class itself, I have the input reader. Can I move this method in to this creation of initialization of the calculation into the calculation itself? Well, I believe I can if I pass the input in there and take these things here and move it into the constructor that I will create. And I have to rename this to input. So what it gives me, let's see what I've got. First of all, my tests are not compiling anymore because or do they? No, they compile. They're still compiling because I'm actually I preserved the input reader here. But look what happened. These two fields can be made private. So let's make them private. And let's make them private. So okay, and the operation doesn't need any set method. So now the last property left to hide is the operation itself. What can be done about the operation? Well, who is interested in the operation? Well, it's the operation factory. So what if I pass the input in here and read the input here, right here, read the operation right here? Then this way I will not need to do this in the operation, and I will not need the operation field at all. So if input read operation, and I will replace this all these things with the, so now I have the compilation errors. Now I have to change on the one thing here is here. So I'm passing in the input. I don't need reader here. And my tests are still passing. And look at this, I don't need input reader anymore. And the operations factory is reading the input. Okay, now let's look at what can be done. What else can be done? The operation. Yeah, it can be made private. So let's continue. This operation is private, and well, it's not used anywhere, so we can get rid of it. So now we have the nice class calculation, and let's look at these classes. They are nothing but delegation. That I don't think this is a good thing to do. And but the only thing they know is which method on the calculation to call. Couldn't be done by the calculation itself. So I think we have lost the opportunity for the we have lost an opportunity for the polymorphism. Yeah, because now this class does too much. It does all the operations, or it shouldn't be actually. But what can I do? What if I will? What if I will inline that methods in here? Then I will need the calculation properties. And what if I
move these methods along with the properties into these things and inherit this instead of inheriting from operation. I will inherit from no, I won't do that. Okay, so let's do this. Let's move these things in the calculation into a subclasses. So let's move the add, push members down. So let's move the add into the subclasses. So refactor. What if I create a derived type? Call it addition. And it suggests me that this class already exists. What if I make this, move all these things from here into the operation class? Now, it'll require me, but I don't need the calculation anymore, and I can call the multiplier from here. And addition, I don't need calculation anymore. I will accept the input. I'll add the base. Initializer pass input to my parent class, and we call add. I'll do subtraction the same way. I'm passing in input here. I don't need the calculation, and base input, and I call this subtract. And the same for the division. I will call the divide, and I will have an input here, and I'll pass it to the base. Okay, and the operations factory. So I don't need this anymore. And the calculation is not used. I will remove it. So, what I have, what I can do is now I can inline these things. I can inline these methods, but prior to inlining these methods, I should make these properties protected. This argument 1 and argument 2, if they will be protected, I can inline these methods here into the respective operations: addition, subtraction, division, and multiplication. Now I have a nice base class. I can remove these methods from here that reads the arguments and calls the execute. Now I have to deal with the number of these arguments. I don't like that these classes, that all classes are reading the arguments. So what I'm going to do is I'm going to refactor this and push these members down. I push this argument 1 and argument 2 into the derivatives so that they can decide what number of arguments they need. Let's refactor this. Push members down. Okay. Argument 1 and argument 2. Okay, great. I don't need it here, but I will have to repeat this thing in all the derivatives. you see, again, I'm introducing a duplication, but is it really a duplication? Well, it is, sort of, but there is another way to deal with that duplication that is not in the scope of this video. So I can make all these things private. Okay, so, and same for the division. It's a read-only fields, and they are both private. What about subtraction? Done. Division done. Addition. This is the private fields now. Nobody needs to know about them. That's the addition. And the same as for the multiplication. So, now, am I in a good shape to implement this negation operation? Well, yeah, sort of, but I still need to deal with that input. But wait a moment, let's see if our tests are still passing and the code is still compiling. Yay, the tests all pass. So, what if I change this input interface to be more generic, and the read argument I will accept the index instead of making this instead of duplicating this method. So the addition, read argument 1, 2. The division, read argument 1 and 2. The multiplication, read argument 1 and 2. And the subtraction, read argument 1 and 2. And I will have to fix the test. So what I'm going to do here is when the input read argument is called with the index 1, it returns argument 1, and the read argument 2 then returns argument 2. Will my test be still passing? They will. Okay, am I ready to test the new operation? Well, not yet. I still have this notion of 2 arguments in this test. What if I convert these arguments into an array? So let's say that I will create an array here with the arguments. And put these 2 arguments into a single array of arguments to the operation. Yeah, then I need to change the signature of my method. Arguments, we will accept the arguments as an array and pass those arguments into execute operation. And here I'm going to make this function to be a function with a variable number of arguments. Yeah, so, and I can pass the arguments to the given input returns. And I will do the same here. It's an array of integer, and I can turn this into 4. Index plus 1 returns arguments index. Look at this. Now, with this variable number of arguments, by the way, I can get rid of these zeros from here. They will work just fine. And with this, I'm ready to implement the negation operation. Negate 132 should be a minus 132. If I run my test, this negation test will fail with the unknown operation exception. So let's go to the operations factory and say if the input read operation equals to negate, then I return new negation. negation given input. I will give it an input. I create this. It's an operation. So private integer argument. There's read only. So the argument equals input read argument 1, and I can implement the execute by returning the minus argument. This will make my test pass. Great. So I have implemented the negation operation. Well, I can do some other refactorings here, for example, convert this, extract this into an operation variable and convert this into a switch. And it gives me a little bit space. Well, the further refactorings could be about this duplication here. I can create yet another derivative of the operation called a binary operation that in its constructor will read two arguments, and subtraction, division, addition, and multiplication can be inherited from the binary operations, whereas negation and any other operations that require one argument could be inherited from another class that reads only one argument. That's the way of dealing with that duplication. But in general, I think we've done well. We refactored all the tests. We have the variable number of arguments to the operation, and we have eliminated all the unnecessary classes, and we did a good job.
That was quite challenging, wasn't it? I mean, we had to do a lot of work to make this happen, to implement the new feature. But now, let's get to analyzing what we have did, what I've done, and finally, as I promised you, the conclusions that I've made out of this lesson, and it's time to explain what that DNA thing means there, why it is there. So, first, I have refactored the unit tests to eliminate the duplication and to pay back the technical debt that I've created when I was first writing code and not paying attention and carelessly duplicating tests. There was the problem that prevented me from moving any further. So first I had to refactor tests. Then I have refactored the code. Yeah, so I have refactored the code and cleaned it up so that I can implement the new operation easier. Then again I had to return to the tests and refactor them once more to make the tests first support the variable number of arguments to the operation. And only then I was able to implement the new operation that requires less arguments than it was previously. So, what conclusions? Well, the test first is always test first. No matter if you're writing a new code or you're changing the existing code, the tests go first. So first you have to refactor the tests if you're doing a refactoring. So first you have to make support for the feature in the tests prior you can implement that feature in the code. So the tests are always go first. And the thing that was surprising for me is that I didn't have, after I did the refactoring of the tests and I mercilessly eliminated duplication in the tests, I was able to modify the code without touching tests much, as opposing to when the tests have a lot of duplication and you have to rewrite and change any tests on any. And why I was able to do this? Well, that's an interesting thing. Because, you know, the tests are describing what should happen to the system. And the tests that I wrote initially was describing what should happen to the system, but also they were setting up the system. And so they knew what to test and how to test simultaneously. When I refactored and removed the duplication, what I did is I separated the knowledge of what to test from how it's being tested. And the how part was not duplicated anymore. So it repeated only once, and therefore if I change the collaborators, if I change the interfaces, I have only one place to go to change this. And which means that if I'm changing the structure of the code, if I'm doing a refactoring, which means the refactoring always means that I'm changing the structure without changing the behavior. So long as I'm not changing the behavior of the system, I don't need to change the tests. And now let's get to this DNA. So probably you all know that the DNA is the code that is baked in the cells of every living being. It's the code that describes the living beings and how they are in most specific details, like what's the color of your eyes, what's the color of your hairs, and so on and so on. But this DNA molecule consists of the two strands, and each of the strands consists of 4 types of amino acids. They are A, T, C, and G. But what's remarkable about the DNA is that these 2 strands are complementary to each other, which means that you can take only one strand and replicate it and restore the another one, because you see the G always comes with the C and A always comes with the T, and so if you have only one strand, you can reconstruct another one by taking the complementary basis. So about the refactoring. When I was doing refactoring tests, then from the books we all know that the refactoring should be supported by tests. But what if you were refactoring the tests? Remember, the tests and the code are 2 complementary things to each other. So basically, when you refactor the test, the code was working. The code was working as expected because you had the passing tests, so you can only refactor tests when they all pass. But if you break the tests, then the code will notice this, because your test will start failing, which means that if you haven't been changing code, then the source of error is the tests themselves. So that's about the complementary, and vice versa. So if you are refactoring the code, you shouldn't be touching the tests, and then the tests will tell you if you do the mistake while refactoring the code. So this is also 2 complementary things that help you check, that help to ensure each other's correctness. So that's why I placed the DNA over there. So that's about it. That's about the story. That's about the problems that I faced and the solutions that helped me solve this problem. So that's about the conclusions and lessons learned. I hope you also learned something. I hope you also will this video will help you to solve your problems in your projects. So, well, this was the very first video from the Software Developer's Diary. Hopefully the next videos will be coming soon, and I hope you will subscribe and not to miss the next videos, and put the likes, and of course I will appreciate any comments from you. Was this video helpful? What's your experience on the test-driven development and refactoring? And well, see you in the next videos. Bye.